Okay. So on any straight demand curve, a straight line demand curve, it has to be a straight line demand curve. The middle of that curve, the exact midpoint of that line, will have a unitary elasticity. Above that midpoint will be elastic. So if we start here at the midpoint, everything below that midpoint is inelastic. Everything above that midpoint is elastic, and that one little point is unitary. But it's only true along a straight line demand curve. All right, so really quick, what affects the elasticity of things? Well, number one, how many substitutes does it have? So how many substitutes does gasoline have? Well, for most of us, you got to put it in your car. You don't really have a substitute. Okay? Yeah? What's that tell you? Well, let's think. For a hamburger, there's lots of substitutes. That means the price elasticity of hamburgers isn't that high. If your favorite hamburger joint really raises their prices, you might go somewhere else to eat. You have choices. When you have choices, you're going to have a fairly elastic demand. You could buy the hamburger, cook it at home. You could go somewhere else and eat. Okay? When there are substitutes and you have choices, elasticity is going to be high. The more substitutes you have, the more choices you have, the higher the elasticity is going to be. Gasoline, I don't have many choices. I don't have any substitutes, at least right away initially. I don't have any substitutes, and therefore elasticity is going to be low. So the more substitutes there are, the higher the elasticity. The fewer substitutes there are, the lower the elasticity. But that's also affected by time. If you give me enough time, right, in the short run when the price of gas goes way up, I just get mad. In the long run, I can buy an electric car. I can take the bus. I can ride my bike. There's a whole bunch of other things I can do. I can buy a smaller, more fuel-efficient car. So if you give me time, I can adjust. When the price of oil went way up in the 70s, people initially just had to pay it. But over time, the average gas mileage of cars has more than doubled. We have all these electric car options. Businesses in America use a lot less energy than they used to. Businesses in America have become amazingly more energy efficient. But they can't do it instantaneously. They can only do it if they're given enough time. So time affects how sensitive we are to prices. And then small proportions. Let's say you're building a house or doing a big remodel on the house, and you've got to buy a couple doorknobs. You're doing a $20,000 project and you got to buy a couple doorknobs. Are you going to care what the price of those doorknobs is? Yeah, probably not. You're going to care what the price of wood is. You're going to care what the price of concrete is. You're going to care what the price of labor is. The things that are a big part of that $20,000 that you're spending, you're going to be sensitive to that. But all these little things like doorknobs, they're just little bitty pieces of the pie. You're not going to spend a lot of time worrying about them. So where wood might be elastic, that doorknob is going to be inelastic, because if it goes from $30 to $35, you don't care, and you're just going to keep buying the doorknobs. Okay? So things that are a small proportion, salt. Salt is a very small proportion of our food budget, and there really aren't that many substitutes. You don't really care what the price of salt is. You don't look. You just grab this salt when you need salt. Okay? Got that? Substitutes, time, and how much of our income it is, those are the things that affect the elasticity. Cool. Okay. All right, so again, we have this straight line demand curve. It has these points on it. How much money are we making at each point? Well, let's look at A. We call that revenue, right? The amount of money we're making is our revenue. At A, we're selling 3 at $7 each. that's $21. At B, we're selling 5 at $5 each. That's $25. And at C, we're selling 7 for $3. We're again making 21. So at A, our revenue is 21. Our C, our revenue is 21. And at B, it's 25. So we have this curve shape thingy, where as we get closer to B, our revenue's going up, and then as we get further away from B, our revenue's going down. All right? Now, let's think about one other thing here. The arc elasticity between A and B was elastic, right? It was bigger than 1. It was elastic. If it's elastic and the price goes down, the price goes down from A to B, right? It goes from 7 to 5. Everybody with me here? As I go from A to B, the price is going down. My revenue is a plus. So I have elastic demand, right? It's elastic right here. The price went down, my revenue went up. Here, the price went down again, but here the elasticity is inelastic, right? It's inelastic. When it's inelastic and the price went down, my revenue went down. Got that? When it's elastic and the price went down, my revenue went up. When it's inelastic and my price goes down, my revenue goes down. So a furniture company might be able to increase their revenue by lowering their price, and an oil company, if they lower their price, they're going to lower their revenue. So an oil company needs to raise their price to increase their revenue. A furniture company lowers their price to increase their revenue. Ooh, it's like a real world business thing. Okay, so again, between A and B, the price falls and the revenue rises. Between B and C, the price falls and the revenue falls. And why is that? Price elasticity is elastic between A and B and inelastic between B and C. It's elastic between A and B. It's inelastic between B and C. It's elastic between A and B. Price falls, revenue goes up. It's inelastic between B and C. Price falls and revenue falls. Okay? Again, this is true on both a curvy and a straight line, but we're drawing this. All right, let's summarize that. If the price falls and revenue falls, I'm inelastic. If the price falls and revenue rises, I'm elastic. If the price goes the other way, if the price rises and revenue rises, that's inelastic. If the price rises and revenue falls, I'm elastic. So if price and revenue move the same, that's inelastic. If they move opposite directions, that's elastic. And if nothing changes, the price goes up or down and revenue doesn't change, then it's unit elastic. It's a 1. Okay? Got that? So I can work backwards. I can see, if you're thinking, hey, how would I ever do this in the real world? Well, I don't necessarily have to calculate the elasticity. I can look at what happens to my price. If I change my price, what happens to my revenue, and then go backwards, and that'll at least tell me whether I'm inelastic or elastic, right? So if I open a furniture store, or let's say I open a restaurant, right? I open a fancy schmancy restaurant. Yes? And I lower my prices. After a week in business, I lower my prices, and my revenue goes up. Now I go, ooh, I have elastic demand. I need to act as if I have elastic demand. So it's telling me, right? The world will tell me whether I'm elastic or inelastic. So let's do some number examples, just to do some number examples. Let's suppose we're selling sweaters, And if the price is $30, the store is selling 100 sweaters. And if the price is $20, the store sells 300. So they lowered their price from 30 to 20, and they went from selling 100 sweaters to selling 300 sweaters. So this right there, those are the Q's, right? And these two guys are the P's. So delta Q is the difference between 300 and 100, right? If you're bored, draw a graph because you're an economist now. You had a price of 30, quantity of 100. Now we go to price of 20, quantity of 300. How much is delta P? Yeah, hopefully you all said 10. How much is delta Q? Well, hopefully you all said 200. Okay? Okay, so we want to solve this, and we have the math there, but let's try graphing it. All right? 30, and I sell 100, right? 20, and I sell 300. So delta P is how much? Yeah, delta P is 10. And halfway between 20 and 30 is 25. We have 100 and 300, right? 100 and 300, and 30 and 20. 100 and 300. Delta Q is 200. And strangely enough, halfway between 100 and 300 is also 200. Okay? I just did that to make the math easy for you. We can put these numbers in here, the numbers from over here. We can put them in here. And if we do the math, we get 2.5, which means this is elastic, right? It's bigger than 1. A 1% change in price causes a 2.5% change in quantity. If I lower my price by 10%, I'll increase my sales by 25%. And that sounds pretty good. Okay? We can do the same thing with revenue. $30, 100 sweaters is $3,000. $20, 300 sweaters is $6,000. My price fell, my revenue rose. Without doing any of the math, that tells me that my demand is elastic. Okay, here's another really simple one. Let's say at a price of 50 cents, a store sells 800 candy bars. At a price of 40 cents, it sells 1,000. Halfway between 40 and 50 is, 45. How far are 40 and 50 apart? 1,000 to 800. Right? And then halfway between 1,000 and 800 is 900. We do that math, we get 1. That's unit, right? Unitary. It's 1. 1. And let's do the revenue thing. 50 cents, 800 candy bars, that's $400. 40 cents, 1,000 candy bars, that's $400. Elasticity is 1. Revenue stayed the same when the price changed.